All right, good morning, everybody. I'm Frank Witmer, and I've got Will, Greg, and Matt sitting here with me as well. And so you have 8 or 9 people online, so a good turnout. We'll record this so that it can be reviewed later on. The slide deck that I'm working with is a compilation of information I've gotten from a few different documents of Johnson Controls. The manual for, actually the user manual was probably the best document that I could find that had the most useful information, but also some videos that they have posted. And at the last page of this, I have a link to all that, so you'll be able to see the reference material. I also included a lot of things on here to have this be more of a reference document than just a PowerPoint for presentations. I think it's like the first 3 or 4 slides might be just like a presentation. The rest are examples and more detail of what we're doing, of what it can do. This morning we're talking about the field inspection tool by Johnson Controls. It's an MSTP tool that not just for Johnson controllers. Yes, there's more information that can be pulled out of a Johnson Controls controller with this tool, but overall any MSTP device can be used. Now I've got on my hodgepodge, I was pulling all this together off of my desk this morning. And I've got an EasyIO controller, I've got a ACI BACnet sensor, I got a Spider controller, and then 3 PCV controllers by Johnson Controls. Just have a little variety of MSTP devices to have worked with the tool. So the field inspection tool, it's a portable device to test BACnet MSTP networks. It is powered by 2 AA alkaline batteries. So it's, if it runs out of charge, you throw in 2 more batteries, you're good to go. I mean, they talk about it was like 15 to 20 hours of use with the battery. So it's pretty good in that way. Micro USB port on it to be able to do firmware updates and also to extract data from this device. And you'll see to the right there, you have the micro USB connection there. You've got your MSTP connection, and then you have an RJ12, so you can plug directly into the FC or the SA port on a controller. And the way I have it set up here, I just have it plugged into one of the end devices on the C. It has the ability to measure the bias voltage levels on the network. It provides FXPC diagnostic information. So it tells you how many devices are online, what the device MAC address is for each device that's online. If it's an FX controller, it'll give you the model number, it'll give you the firmware version that's in each controller. It'll tell you if the end-of-line switch that's built into those controllers, if they're turned on or off. That's a quick way to check to see if you have you have the end-of-lines in place, especially if it's an all-Johnson network. And it also measures 485 voltage levels. And then it also monitors the communication, so it will report any communication errors that it finds. The different modes of operation, you have the monitor mode, tells you what devices are communicating on the network. There's a scan bus mode that will read the attributes of the controllers that are communicating on the bus and reads the end-of-line termination attributes of the controllers. Again, just the Johnson Controls controllers. I mean, if you have a 120 ohm resistor at the end of the network, it's not going to tell you that. It doesn't know anything about that. But you'll see when you look at the communication voltages, you'll be able to tell if you have the end of line on or not. There's a mode that if you have a standalone controller and you want to test it, it's called one-on-one mode. Allows you to go ahead and connect to it. You can see what the controller model is, what the firmware versions are. You can test the MSTP or even the SA port and look and see what's on the network to make sure everything's okay there.
So we'll test the communication?
Yeah. The actual device itself has up-down arrows for moving through your menus. There's an enter key to go to the next level or perform an action. The escape key is to cancel, go to a previous menu. Then you have your on-off switch on it. Some of the menu items that are on the fit, you've got, when you power on, it comes up and gives you if there's devices offline or online. And then if they're online, it gives you, you'll see on all the way to the right here, this is actually like a bunch of bars to give you the how good the network communication is. 8 is excellent. I've read, I think it was less than 4 or 4 and less bars or blocks means it's a bad network. I tried to on my network. I added some, a few feet of wire for the network between devices to kind of add a little length to it or whatever. And I don't think I've ever seen it go below 7 bars. I think I've always had at least 7 or 8. Plus, I switched wire types and things like trying to make it a nasty network just to kind of see what could happen. Never got to do anything other than the normal, I guess, because it's a short network. The scan bus option or menu item is where it'll go out and communicate to all the controllers on the bus, and it'll gather information. And if there's no communications going on in the network, it'll actually try to invoke communications on the network. So if you have controllers and you don't have your JSON there yet, when you're bringing the system up, that could be the one that everything will sync to for the auto booting of the controllers. There's an issues menu item where it'll report the last 5 communication errors and other bus issues when you're connected to the network. I've got a slide on here with a list of issues, and it gives you then an explanation and what to look for, type thing. The monitor bus menu reports on the status of all the controllers connected to the MSTP bus. The monitor mode only listens to communications on the bus. It doesn't record, the end of the line, whether it's on or off, the model, those type of things. One-on-one, as I mentioned, it's to report the status of a single controller, not a network, not networked controllers. The voltage menu is used to measure the idle voltage of the 485 bus and also the bit voltage of the communications. And then there's a report menu where you can save a report, and actually what would happen when you do an upload, it streams it back to your computer. So if you have a spreadsheet open, it'll auto-populate the cells with the report information, or if you have an editor opened up, it'll do tabular format, so it brings all the data in that way. You could also set it up to be able to do CSV if you wanted it to work that way. And then you have your system menu, and in there it's sort of like your settings for fit, the backlight controls, the end-of-line termination mode. There's an install versus an export mode. You can test your battery and make sure it's okay in the fit, the baud rate in the fit, its address, and power off functions, things like that. Some of the key features: it's exclusively used for diagnosing and troubleshooting and also documenting MSTP communications. You could have it on a FC bus on your MSTP network, and it will look at anything that's on its segment. You could have it hooked up to the sensor actuator bus as well, and it will actually report on your devices connected to the SA bus. So if you have multiple network sensors on there, it would go through and list those devices. So you would plug into an SA port anywhere on the network, and it would report that information for you. It measures idle bus voltages that's in between messages. So that's where you really can't read that with a voltmeter because it's too quick. And the way the screen works, the top line is the voltage from your plus to minus on the MSTP port. The left side is the plus to common voltage, and then you have the negative to common voltage. So realistically, your plus to minus voltage is just the difference between your plus to common and your minus to common. So it measures your idle voltage. It can record and display what's connected. So it'll tell you, in this case here, you've got 7 devices, and then you can scroll through and look at what the addresses are that it finds. If you know you're supposed to have 10 devices on the network, you can scroll through here and verify that you have all those online. Also can calculate, display, and record the bus health index. That's the bar of 8 blocks here. 8 meaning 100%. Then you have on the issues screen, it'll report and record specific issues that may be found on your network. Here they're showing a character framing error. Here they're showing it occurred. There's a token passed between controller 5 going to controller 6. And then they also, as I mentioned, you can tell which JCI controllers have their end-of-line switch turned on. So it'll come up and say EOL on or EOL off.
The reporting of specific issues and problems, does it give you suggested courses to fix it?
Well, that doesn't, but there's the documentation does. Like in the user manual, it had some things. That's why I have it as one of the slides on here.
All right.
With some of those, examples.
Okay.
Here. So here's the menu of, or the slide of some of the issues that it comes up with, or that it can find. You got your bad frame, and then you'll see there's a column for description, and then you have potential corrective actions.
Gotcha.
So I pulled that was a bunch of different places, so I kind of pulled it all together on one slide to make it easier to be able to look through. Online just means the last time it was offline and it found that it was on. This time around it came, that was back online. Your character framing, second token, which is MSTP token, was retransmitted. The good thing about it is there's a description plus some corrective actions. I mean, that's half the problems with a lot of the messages that we find, errors we see looking through, on a JACE, reporting, the MSTP network and not having a clue where to go from there. There's not really much information. And this will be available, like I said, as a PDF up on our bptechcenter.com. Like the bottom there, out of sequence, device on the bus talked out of sequence or attempted to communicate without the token. That's where it looks like they're talking about that there might be more than the end devices with the end of line turned on. So it is a nice way to start looking at a network where if you have all Johnson controllers, start out making sure your shield is terminated properly, and then you can go in and you have however many 15 devices. So the first thing you might want to do is look to see if your 2 end devices have the terminator turned on or their EOL turned on, and then start working from there. If we look at the voltage menu, these are the 3 different modes of voltages that you can read. The first, as I mentioned, is the bus idle voltage, which is the voltage when the communication is idle, inactive. It's inactive. And it's plus the common, minus the common, and then the idle difference in voltage between those 2. And one note to keep in mind is proper bus voltage levels won't be displayed unless the end-of-line termination is present, whether it's the EOL switches on the Johnson controllers or you have your 120 ohms in place. You got biasing you got to look into. I mean, Johnson Controls doesn't talk much about biasing, but those EOL switches does enable a biasing circuit in there, not just the end-of-line termination. bit voltage is the voltage when the communications is active. It's basically the amount of change of the voltage as it's communicating. So it's difference in voltage in the plus and the minus. Well, it displays the difference voltage between plus and minus at a half-second refresh rate. It's also referred to as the communication voltage. And then also it can be set up as a meter. It basically turns it into a voltmeter, and you can measure the current voltage that it sees on the bus. And as a note here, this mode can be used to look at voltage bias levels or to determine if there's any voltage caused by noise or improper wiring on the network. And then a little bit on the communication voltage levels, or the bit voltage. And as it says there, the FIT will measure the communications voltage levels of each individual controller, and it can be affected in many ways. Wire length, gauge, if there's a change in wire type could cause problems, the topology of the network, your end-of-line terminations, or also even if, with the FIT in place. The FIT has a setting in there where you can turn on or off the end-of-line termination in itself. So if you didn't have a Jace on the bus yet, but the Jace was going to be your terminator, your end device, you could plug your FIT in at that end and have it have its end-of-line turned on, so you can see what a complete network would be once the Jace is hooked up and you have your end-of-line termination in place. The bus end-of-line termination provides about 0.4 of a volt of bias voltage, and that keeps the bus in a high state when communications are idle, meaning slightly above 0 volts when it's idle. The end-of-line also provides proper bus termination, where we're used to seeing an end-of-line resistance value that would be basically the same as what the impedance is of your cable, and usually it's 120 ohms. And then ideally, your readings, plus in common and minus in common, their values, the difference between those two should be equal, but no more than 0.2 volts between them. So if you read more than 0.2 volts, it could be there's a loose connection or some other cable problem near the address that's displayed or the controller itself. So you actually, if you see one controller with a different voltage and it's more skewed, then it could be something with wiring close to that device. So somehow it knows the voltage at each device when it's reading the device. The only way I can think of it doing that is that the RS-485 or the MSTP communications has that information from the controllers themselves. And the nominal differential voltage is that you'll see between 2.5 and 8 volts. The idle bus voltage, when you have a proper line termination, you should be reading between 2.7 to 2.3 on the your plus to common, minus to common, and the differential would be 0.4 volts. That's typically what your target is that you want to see if the bus is terminated properly. So the plus common at 2.7 volts and your minus to common at 2.3 volts. And again, the difference voltage would be 10. And the idle bus voltage can vary with wire length and bus loading, but should not be lower than 0.2 volts or higher than 0.9 volts. And it's also possible to read minor fluctuations while reading the idle bus voltage. These minor changes are normal, so you'll see it bounce a little bit. Reading the idle bus voltage levels. It's a good way to see if there's any wiring mistakes. And if you discover there's voltages outside the recommended ranges, here's a little chart that gives you, some symptoms and then you know, the possible resolution for it. So if you look at that first line there, your idle voltage, the differential is 0.4, and you're sitting in 2.7 for plus the common and 2.3 from minus the common. You know, so you're at that 0.4, so you're right on where you should be. So that's a good network right there. The next one down is showing 3.6 volts on your plus to common and only a half a volt on your negative to common. So your differential voltage is high, it's 3.1. And that can be that you have a cut cable, you're missing your end of lines. And then the issues menu may show up second token as an issue as well. So there you want to do is they say look at your as-built. So look and see where basically they're saying look where your end devices are, check to make sure you're terminated. And also check to make sure nothing's terminated in between too. You know, it can only be the end devices that have that. The next one down, it's a low differential voltage, it was 0.2. On that one, it could possibly be your end of lines are on, but no power at the controller. There's no issue that would come up in the issues menu on something like that. But this symptom is your plus and minus that's common drop too low. So let's look for the quantity of devices on the bus and check that the end of lines. Check the end of line on your fit to make sure it's not turned on. By default, it's off. I would only turn it on if you knew that you were missing a terminator at one end and you wanted to connect to look at the bus, and you would just plug in at that end device and basically put the termination on for it. So again, these are just some examples of potential readings that you'll get and then what to look for. You know, like here's one here. Your plus to common and minus to common are exactly the same, so you have no differential voltage. That'll be a character framing error that you'll see in your issues menu. And there, you know, the recommended solution could get down to where you're, you know, divide and conquer. You split the bus in half and check that half and, you know, work your way down to try to figure out what the problem is. These are a couple I pulled off of the videos that they had online. Just giving you some other examples of what you might see and then possible resolution for them. So again, it's a good, you know, reference document when you're trying to troubleshoot your network. We move on to the one-to-one communication voltage levels. Again, this is for a standalone controller, but you're able to still go in and read those values. I guess you could also use it if you suspect a single controller is causing the problems. Disconnect it from the network, go to one-on-one and look at it directly without on the network.
Yeah, that's the only way I would think you could use it. I mean, why would you need communications on a standalone?
Except if you were looking at the SA bus, you were doing some averaging of temperatures and you wanted to see what was going on. Proper bus terminations. Obviously on MSTP networks, it's recommended to have an end-of-line termination at the end devices, one at each end. It provides the proper bus termination and Johnson Controls case biasing on the network. Because theirs is more than just a resistance in there. I mean, they have an end-of-line device that you can put on the network if your device doesn't have, if it's not a Johnson Controls controller. It's 24 volts power to it. It connects to the plus to minus and the common, I believe, and it adds biasing voltage to the network. Obviously, it's required for a reliable communications network. As I mentioned, if it has those end-of-line terminators built in, then you can turn on or off, and they're off by default. And as I mentioned, if you're look at three voltage levels, and you can look at your idle bus your communication voltage and your meter voltages. The next part is the reports. You can have up to 7 reports saved on your device. So you can go in and, you know, look, they call it validating the network, but you could go in with this device, communicate with the controllers, scan the bus, see what's going on, and then you could actually save the information. The information would get saved to the FIT, and then when you got back to the office, you could do your upload. You wouldn't have to do that while you're live on the network. And you could set the format of the report up as tabular format or CSV. And basically, you have that, whatever style you want, you have your editor or your spreadsheet open, and when you tell it to upload, it'll start filling in the fields of your open document on your computer. And then some of the information that it saves for you is general bus information, the health index, number of devices. It'll give you what the idle voltages were, any issues reported, device information, so it'll give model type. It's differential communication voltages get recorded, whether the end-of-line termination was turned on or not, if it was a Johnson Controls controller, and it also captures the issues information. So as an example here, you'll see you have your general information at the top, and then you have device information, and then your issue information. This one here is, I pulled this is my network that I have on the table right here, and I had my Microsoft Excel opened up. I told it to do an upload, and it just filled in all these fields for me. In my case, I've got 7 devices, and of these 7 devices here, one of them is the map gateway that I have connected. I actually have 3 PCVs. I didn't leave it on long enough to test or to pull in the information from the 3rd PCV, but I also had a Spider controller. I have an EasyIO FS32 and then a ACI BACnet sensor. So it did list all those devices, and it listed all your MAC addresses. And then on the issues section, it gave me the information of what it found on the network. So that's something, as I said, you could save it on site, and then you could take it back and upload from that device. In the last couple slides, we're on troubleshooting, some tips and best practice type things. You want to validate the controller, make sure they're powered up and undisrupted, to make to do your scan of the bus. Check your wiring, verify your end-of-line terminations. Along with that, you want to make sure your shield is only terminated to ground at one end, but connected all the way through. Check your addresses, make sure you don't have duplicate addresses. You don't want to have any T-taps, star configurations. It's daisy chain that you need to use for BACnet MSTP. Make sure that all your baud rates are set the same. Most devices these days are auto bauding. I know, like my ACI wall module is there's dip switches for setting its address. And then check for sources of electrical interference. These are all if you're having issues. So when you're working with this, you can check and confirm your idle voltage levels on each bus segment. If you have to, cut your bus down to smaller pieces, divide and conquer if, you are having problems to try to help find where your issues are. And then check your idle voltages on each of those smaller segments. Or if you, like I was saying, if you think it's down to one controller, go to the one-on-one mode and just look at the one device by itself. You know, and then go from there. And as I mentioned, these are the sources I use to pull a lot of that information together. The best document I found is their FIT user guide. It's really good. There's a lot of real good, valuable information in there, and a lot of that I captured in this document, so you have this to refer to. But then also each of the videos that are shown here as well, so you'll have those links there. So with that device, with the FIT, let's see if I can do this. This is where I get klutzy trying to, how did earlier I did that, it was, I could read it. Let's see. What's that? Oh, yeah. I was sleeping right now. We turn it off and turn it back on. So you can see when it first comes up, gives you the version number of the firmware in the FIT. We've got 8 bars, so that says it's, you know, it sees it as a good network. You got your up and down arrows. So if we go up, the first thing I usually like to go to is the scan. Oh, there it is. Go to scan, and then it comes up and it's scanning the network. So while it's doing that, I can go through, okay, it found 7 devices. Address 2 I know is my map, and 4, 5, and 6 are my 3 PCV controllers. And I have address 7, 11, and 12 as well. So I could go in from there, and there's your idle voltage. I can see of each device, so you know I'm scrolling through to see what's going on with each device in there. If I back up 1 level, and I go to, let's go to one of these. Let's go to 4. That should be done. I go here to this controller. Okay, that PCV. We know it's PCV because it's reading that there's an EOL in there. Otherwise, it wouldn't have off or on there. So that one, then the line is turned off. It's a PCV 1630 by JCI, and then you can go through and see its voltages. I could come down here and go to this one. There, it's unknown because it's not a Johnson device. It is a Spider controller. It's third party. And then you get your voltages on there as well. You go through the same thing. This is the ACI device. Sorry, Bob. If you're able to look at all those. So if we wanted to, we could go back and look at our voltages. Look at our idle voltages. Our idle voltage is high. If we go through each device, we'll see that we don't have the termination on this network. So I could turn around and come in and turn on the 2 end devices, and you should see it drop. Yeah, okay, it did drop to 0.4 is exactly what you should be reading when you have your bus properly terminated. So now that idle voltage is correct.
That's 0.4.
And then based on, you know, if you go back and look at that document that the PowerPoint I had, they talk about plus to common should be around 2.8 and or 2.7, and your negative to common should be around 2.3, and it's dead on. So you can come out, go back and see. So that, you know, so that looks good. Now if we go back and look at our go back to the scan bus. Look at your communication voltages from there. Let's see. Let's get back to our volts again. So that was our idle voltage where, that looks good now because we terminated the network. Go down and we can look at our communication voltage. I noticed the communication voltage is much less on the ACI wireless. ACI wireless device. I haven't had a chance to investigate it further to see why that one device had a much lower voltage level.
We need to figure out what these things cost.
And then I mentioned you have the meter. So now we're reading it as a voltmeter. So plus the common is reading, it's bouncing around 2.7 volts nominally. And the negative common is the bottom line. The reason it's fluctuating so much is because of why there's any other communications it's able to, it's picking up on those voltages. That's the one they talked about the most, yeah. Because it has to be clean. If the bus isn't clean, your idle voltages will be higher, which makes it more difficult for them to read the voltage for the when you're communicating. And if we go to, we didn't look at issues, so if we go and see if there's what issues might be there. Right now there aren't any issues. But when there are, I think we saved up to the last 5, you can scroll down and see what they are. Monitor is instantaneous information. It's not giving you, it's not saving any of the data. We go in. Showing you the tokens. If you go up to go to reports, we're able to go in and view various reports. I have 2 of them saved in there right now. Actually, my micro A cable, I have a zip pocket. It's in this section, I think, where the laptop goes. But if there was information you thought was worth taking back and looking at a report, when you go to reports, you can name it, whatever you want to name it, and then you hit save, and then when you're connected to the computer, we can do a upload. And I'm going to grab my cable. And then what we can do is, thank you. Like this, and then, as that one shot showed, there's our connector there. Plug that in, and hook that up to my computer. And if we switch back, actually, what I want to do is open up Excel. Just take a new spreadsheet. I'm going to go back to my, so if we want to view, we'll look at test 1. And from here, all I'm going to do is I'm going to hit the upload button. And if you watch on my screen, there it goes. You see how it automatically fills the fields in. So it's basically just streaming that data right across. and if you just had an editor open, Notepad or whatever, it would be, you know, tab formatted. Or if you went back into the FIT, you could set up to be CSV, and it'll do comma separated values for you instead. It's almost like old technology the way it's doing it, but I guess it was a simple way to transfer the data. So there's your report, then you can do a save and print it out or do whatever you wanted to do with it at that point. Or maybe something, there's some weird data there you're not sure of, then you would shoot it off to us to review maybe, would be, you know, a possibility. So it's a way of, I mean, it's not an oscilloscope, it's not giving you the waveforms or whatever, but it's giving you, at least it's giving you voltage levels that make sense based on whether it's idle or communicating, plus, you know, to give you the information of what devices are online and, you know, those type of things. So it's a good device, whether it's a Johnson Control System or mixed system, or even if there's no Johnson Controls devices, it's still worthwhile. I mentioned that you could plug it in, and let me switch back. I'm going to turn around and plug this into an SA bus now that has one of the new NS sensors on it. I'm not sure if you guys have seen them or not, but this is the one of the new NS sensors. So now if we go back to get this back up so we can see it. Scan the bus, finds two devices. So now if we scroll down, 199, so scan again. 199 is the address of the NS sensor. And I guess the 0 is this FIT device. But it's a way to at least go out and scan and see what do you have out there. If you got a bunch of sensors on the network, it's an easy way to check to make sure they're all addressed properly. And it also has a voltage level to it, as it is a RS-45, a pseudo MSTP type network. From what I can tell in testing we've done, it's more of an MSTP network where each device has an address, a MAC address, but it's not using instance numbers or anything like that. So there's no way to have it communicate directly on an MSTP network. We've done a bunch of testing to try to find ways to do it, and they're set up to not be made that way.
Got to use it with our device. Got to use it with the Johnson controller.
Right. But the new NS sensors have a third dip switch with the addressing. So it goes from 199 to 207 or 8, somewhere in there, I think. And it uses much less power, so you can actually get more devices on the network, on the SA bus, than you could in the past. But that's the FIT. Field inspection tool is what it stands for. But any questions, any comments? Are we still there?
I'm still here.
So what are your thoughts? A worthwhile troubleshooting tool?
I am wondering how it compares to some of the other stuff that's starting to come out with the contemporary controls and Optigo. It seems like that market's starting to perk up with BACnet troubleshooting tools.
Right.
some of the voltage information I've seen before. In a sense, for me, it really comes down to the cost of the device.
Yeah.
And the ease of operation.
Versus some of the stuff that you can do with a meter. I mean, the Johnson specific stuff's nice if you're doing a lot of JCI work.
Right.
Contemporary controls one was pretty easy to do. The Kruger documents also have a diagnostic. The Kruger
You can't see.
KMC, rather.
Okay. Well, so that's it. Thought it was worthwhile to do it on one of our monthly meetings just to get the information out there and to show what it can do, and it is fairly straightforward to work with, and I think at times it definitely could be useful. But pricing wise, I'd say get with your friendly Brody salesperson for price.
It's funny that he started laughing.
Yeah, what was that about?
Or Brody saying
My friendly sales team.
Absolutely. You're
No,
not
I mean, yeah, the price point is probably on par with everybody else's. It's just if I'm looking at putting one of these in everybody's truck, it tends to get a little expensive, and it's not good if I only have one sitting in the office.
right.
But I think one of the biggest takeaways from this is the information about, how to troubleshoot based on voltage.
Right. That's why I threw a lot of that into that PowerPoint, so it's you look in one place to get some of that information. Yeah, you're right, because it applies to more than even just using this device. It applies just in general with your troubleshooting.